In this video, we would learn how to solve system of equations. The first thing is we have to write down the system of equations into a matrix form called augmented matrix. So these are just like you can write down these coefficients here. So from the first equation, the coefficient of x is 1, y is 1, z is 1, and then constant is 9. Just write them down. So 1, 1, 1, and 9. From the second equation, the coefficients are 2, negative 3, 4, constant is 7. From the third equation, this is 1, negative 4, 3, and then negative 2 as a constant. So this is our augmented matrix. And to solve this one, so we are using Gauss-Jordan method to solve this system, right? So what we have to do is that we would have to perform row operations to change this matrix to look like something like this one. So you have 1, 1, 1 in the main diagonals, above and below you have 0, and in the last column, so you would have some real numbers, right? Here I write them A, B, C, so it could be any number like 2, 4, 6, negative 3 or whatever, right? Some number. Alright, so let's start. So now here we need 1, it's already there, so okay, so go with the next step. So we need 0 and 0 here, right? So to make this 0, I multiply the first row by negative 2 and add into this. So this is how we write. So negative 2 times row 1 plus row 2 is new row 2. And to make this 0, I simply multiply by negative 1 row 1 and add into this. So negative 1 times row 1 plus row 3 is row 3, which is the same as row 3 minus row 1, right? So like in this way. Okay, let's do it. So now here we see that changing row 2 and row 3, so row 1 would be as it is. So 1, 1, 1, 9. So now multiply row 1 by negative 2 and add into row 2. So negative 2 and plus 2 would give us 0. So negative 2 times 1 is negative 2 and plus negative 3 is negative 5. So negative 2 and then plus 4 is 2, and negative 2 times 9, negative 18 plus 7 is negative 11. Alright, so now for row 3, so subtract row 1 from row 3, right? So 1 minus 1 is 0. So negative 4 and minus 1 is negative 5. So 3 minus 1 is 2, and minus 2, and negative 2 and minus 9 is negative 11. Now from here you can see that row 2 and row 3 are similar. Right, you see that negative 5, 2, 2, negative 11, negative 11. So this is an indication that this system have infinite many solutions, right? So let's do, okay, first, okay, so make this 0 now, right? So adding row, subtracting row 2 from row 3, or multiplying row 2 by negative 1 and adding to row 2, right? So this is how we write. So negative 1 times row 2 plus row 3 is row 3. So 1, 1, 1, 9. So 0, negative 5, 2, negative 11. So now multiply by negative 1 and add into this. So negative 1 times 0, 0 plus 0 is 0. negative 1 times negative 5 is plus 5, plus 5 and negative 5 is 0. So negative 2 plus 2 is 0, and negative 1 times negative 11 is 11, 11 plus negative 11 is 0, right? So one entire row turned out to be 0, right? So okay, this would have infinite many solutions, and there is no way so we can create one here, right? And one here and here like this one. So once one entire row is 0, so then there is no way that we can create this form, right? This one. So but still we can create 1 here and 0 here, right? So 1 and 0, but here would be problem, we cannot create 1, right? And similarly we have difficulty, okay, getting zeros there. Okay, let's do as much as we can. So to make this 1, so I would divide by negative 5, which is the same as multiply by negative 1/5. So negative 1/5 of row 2 is new row 2. So that's 1 1 1 9, and that is 0. So then multiply by negative 1/5. 0 times negative 1/5 is 0, so that would give us 1. Then that is negative 2/5, and negative 11 multiplied by negative 1/5 is 11/5. And then third row is 0 0 0 0. Okay, next. Okay, so to make this 0, so simply subtract row 2 from row 1. So negative row 2 plus row 1 is due row 1. So that's 1 minus 0 is 1, 1 minus 1 is 0. So 1 minus negative 2/5, so it would become plus 2, and that would be 7/5. And 9 minus 11/5, so that would be 45 minus 34/5. And then 0 1 negative 2/5, 11/5, 0 0 0 0. All right, so as we cannot proceed further, so we cannot create 1 here, right? So while and make zeros here without disturbing the achievements that we have, so we just stop here and then rewrite our equations. So from the first row, so we can write as coefficient of x is 1, so that would be x. So coefficient of y is 0, so it's 0. Then plus 7/5 of z, so that is equal to 34 by 5. And from second equation, so you would have y minus 2/5 of z is equal to 11/5, like this. And third equation, third row, so that is 0 is equal to 0. That's not new information, right? So we just ignore this part. So now we have, see, there are two equations and we have three variables x, y and z. So in this situation, so what we do is that we assume that, so let's say z is equal to z, and then solve these two in terms of, right, so for x and for y, right? So solve that x is equal to something, y is equal to something. So this would imply that this equation, x is equal to 34/5 minus 7/5 of z, which is the same as 34 minus 7z over 5. That's a common denominator. And from here, so this would imply that y is equal to 11/5 minus it's become plus 2/5 of z, or which is the same as 11 plus 2z over 5. And then our solution would be, so solution, so this would be then x value, so that is 34 minus 7z 5, and y is that 11 plus 2z over 5, and z is equal to z for all z, right? So for all z. So that's your answer.